Dr. Evans, just thank you very much firstly for joining me today and talking with me. You're a mathematician.
Yes.
You're an engineer.
Yes.
You have 6 university degrees.
Yes.
You're the brains behind FullCam, which was software that you wrote for the Australian Greenhouse Office. It's used by the Australian government to actually measure compliance with the Kyoto Protocol.
That's
is that?
It estimates Australia's carbon in our biosphere.
Okay. I've read that you said about yourself that you became a skeptic in 2007. Now that sounds almost like a religious conversion. So firstly, just tell me, what was the work that you did for the Australian government and what brought about that conversion?
For the Australian government, I built FullCam, which is a carbon accounting program. We needed to know for the Kyoto Protocol how much carbon was being released by mankind in Australia. And we looked at the agricultural and land use change sector, which is mainly forestry and cutting down trees for clearing. We estimated, using FullCam, how much carbon there is in Australia's forests, plants, mulch, debris and soil, and the changes due to human activities. Why did I change? Well, while I was working for the Australian Greenhouse Office, I kept a track of the evidence, because people used to ask me at dinner parties, oh, how do you know there's global warming? How do you know it's due to CO2? Well, I wanted to be able to answer them. So I kept a track of the evidence for and against as it evolved from the year 2000, when I started that job, to about 2006. I left the Greenhouse Office in 2005 for reasons that had nothing to do with my belief or otherwise in CO2 theory. But by 2006, it was pretty obvious to me that, in fact, there was no crucial evidence that our CO2 was causing global warming. Some of the crucial evidence they don't talk about is missing. And in fact, the evidence was starting to pile up the other way. So I changed my mind.
So for you, it was very much a case of you were keeping on top of it so that you could answer your own potential critics and help people to understand the work that you were doing for the Climate Office itself.
No, not so much potential critics, just people wanted to know. I wanted to know. I was curious. I mean, I thought I was in there with the Greenhouse Office doing a very important job in saving the planet, doing carbon accounting, working out how much carbon was going out there. And I threw my life and my heart and soul into that project. So I wanted to know why. Was it worth it?
In 2008, you publicly described the ETS as completely unnecessary in an article that was published by the ABC. Now that's a very public forum on which to make such a statement, and it's a pretty strong statement, completely unnecessary. That's 2008, so we're talking only 2 years or so after you're saying you really began to change your mind. That's a very, very radical shift. So on the ETS specifically, which obviously was never implemented, it was then reinvented and brought in by Gillard after the following election. But why did you say it was completely unnecessary? There are many people telling us the very opposite.
Small correction, I started changing my mind in 2002. That's when the first things came across with the ice cores. It is completely unnecessary. By 2008, we already knew the temperatures had plateaued, even though carbon was still rising quite quickly. The crucial part that they don't tell you in their models is, yes, CO2 is a greenhouse gas and yes, it causes warming, but it doesn't cause nearly as much warming as we've seen in the last century. For that, you need an amplification effect due to water vapour. Okay, this amplification due to water vapour is responsible in the climate models for 2/3 of the past warming and 2/3 of the projected warming. So only 1/3 of the warming that they're projecting comes directly from the CO2. The other 2/3 comes from what are called positive feedbacks due to water.
And that's accounted for in the current models. That's how the current models handle it.
Oh yes. But by 1999, the evidence had already come in that amplification was simply not occurring. It was finally released publicly in 2006 in an obscure journal, and they tried to hide it, but it's there, it's on the record, that by 2006 we knew for sure the amplification wasn't occurring. And in fact, it looks like the opposite occurring. It wasn't amplification that actually occurs in the atmosphere, it's dampening. So we get even less warming than would be due to CO2 alone. So the amount of projected warming is cut by 2/3 due to lack of amplification, and a further cut in half by the fact that we've got dampening instead of amplification. So we do not need to cut back the amount of carbon we're putting in the atmosphere, and an ETS is therefore entirely
completely unnecessary. Yeah. I want to rewind because you're making a number of statements, and I want to get some idea, a bit of a handle on how you know or why you believe you know these things. You said, for example, the temperatures have plateaued.
Yes.
According to who? Because that's quite contrary to a lot of
Well, there are 5 main temperature records in the world that are kept up to date. There are the 2 satellite ones, University of Alabama and Huntsville, UAH, and RSS, Remote Sensing Systems. And there are 3 ones based on land-based thermometers and a few sea-based thermometers. That'd be Hadcrut in England, NCDC and GISTEMP in the United States. GISTEMP is run by NASA. All 5 of those have been reporting cooling since 2005 and a lack of warming since around the mid to late 90s. So they're the 5 authoritative temperature sets, they all say no warming since mid to late 90s, depending which set you look at exactly and what criterion you put on them exactly. And they all say cooling since 2005.
Well, that's interesting, because we do still hear about record high temperatures, though. We hear about it in the media. We do still hear, for example, people reporting that X many 5 of the last 10 years or whatever have been the warmest on record. So how can you be saying it's paused on the one hand, and yet we're seeing something radically different? That the information coming to us through the media and so forth.
Well, I don't necessarily take what comes through the media with complete, it's not the last word in it. I go straight to the data. Anyone can download. You can just Google and find out the data yourself. You can download it. It's a wonder that journalists haven't done it. It only takes 5 minutes to Google and say UAH temperatures, download them, put them in an Excel spreadsheet, and put a trend line through it. It's very simple to do. If journalists would simply do that, they would realise that they're being sold a little bit of a line by the climate scientists.
Now, in 2009, you took what I would suggest is a step further in your progression, if I can call it that, when you said that concern over rising ocean temperatures was going to be a new trend in climate alarmism, that this ocean temperature issue was going to become a big one. Now, many people are actually expecting the AR5 IPCC report, which is upcoming, to do exactly that. We're expecting that to really emphasise the issue of what I think is referred to as ocean acidification. Talk to me about that. Why were you saying that's going to be the new trend? Isn't that a serious issue? Aren't we observing that?
Not really. The reason we know it's a new trend is because atmospheric warming, these are the air temperatures I was referring to, has stopped going up. They plateaued in the late 90s. So the warmists need something else. They switched to ocean temperatures, and they did it very publicly in 2009, shortly before my comments. They dropped air temperatures and started talking about ocean temperatures. That's how I know it's what they're focusing on. Now, ocean temperatures are a very interesting topic. It's very cut and dried. You see, before 2003, we didn't know what ocean temperatures were. Yes, we had ships going around, occasionally dropping down thermometers into the water or firing XBTs, diving darts down to 700 metres. They drop down through the water and they transmit the temperature as they fall through the water back up to the ship. But they drop through the water too quickly. They don't equilibrate with the temperature around them. They give you a rough idea of the temperature. And there were very few of these. They only existed on commercial shipping lines sporadically, and most of the world's oceans are in the southern hemisphere, and we're thousands of kilometres away from the nearest measurement. So until 2003, this system basically gave us very little idea of what the temperature in the ocean was. The uncertainty bars on it were like 2 or 3 degrees, and we're trying to talk about temperature rises of 0.01 degree or maybe 0.1 degree over a few decades. Ridiculous. But in 2003, the Argo system was deployed. The Argo system of ocean buoys has a bunch of buoys that are Argo things are about 6 feet tall. These buoys dive down to 2,000 metres and come up very slowly, equilibrating with the temperature around them as they come up, come back up to the surface, radio back via satellite to headquarters with the temperature data they got. They do one of these cycles about every 10 days. And there are 3,000 of these things deployed all through the world's oceans. So finally, we're starting to get some idea.
Some reliable data.
Some reliable data on what the ocean temperatures are. But we've only had it since about March 2003.
Right, okay.
Now, prior to March 2003, the warmists would tell us, and they always show in their diagrams, massive ocean warming was rising very quickly. But come March 2003, suddenly it stops. Suddenly the Argo program, the first few years of the Argo program, it showed ocean cooling. Well, they threw out some of the measurements and replaced some of the colder buoys with better warmer, so they adjusted it a bit. And it still shows basically no warming. We've been measuring the temperature of the ocean with the Argo buoys since 2003. It's now, what, nearly 10 years. Yeah. It shows essentially no warming, certainly much less warming than the uncertainty in the measurement. It is fair to say the oceans are not warming.
And certainly there's no statistical significance to any warming
certainly
being
not
measured.
Now there's an argument about deeper oceans versus shallower oceans. The combined oceans between them are not warming, and they're certainly not warming at anything like the quick rate that the climate models are suggesting they ought to be warming. So while they want to talk about ocean warming because air temperatures have plateaued, if they get the debate started on ocean warming, the public will eventually come to realise that that isn't warming either. And the crucial thing you've got to understand is we only started measuring it properly in 2003, and since then it hasn't been warming.
Now, Dr. Evans, one of the recurring themes of the climate debate, one of the things that you'll see over and over again, is this question of who actually has the authority to speak on the subject. The IPCC obviously claims a great deal of authority, claim that they have a great many very, very highly credentialed scientists working for them. We see claimed that there is, for example, a 97% consensus of all the world's climate scientists who agree with the underlying theory that man is causing global warming. Now, I notice in amongst your degrees, you don't have climatology. You don't have anything that would apply specifically to this field. You're a mathematician, you're an engineer. I'm sure you're very good within your own fields of expertise. Why would someone listen to you, though?
My authority comes from the data. We had something called the Enlightenment from about 1650 to about 1800. In the Enlightenment, reason triumphed over intolerance, superstition, and abuses by the state and by the church. The main outcome of the Enlightenment was that we learned that empirical evidence is more important than any person's say-so. And so the field of science was born, where data triumphs over theory. Mm-hmm. Now, before the Enlightenment, we had the case of Galileo versus the Pope, for instance. Mm-hmm. The Pope was infallible. Mm-hmm. Therefore, what he said was right. All the experts at the time agreed with the Pope because he'd brought a consensus. Mm-hmm. And yet the data said that Galileo was right. Mm. Well, it turns out that Galileo was right. Now, on the climate issue, we've sort of gone back to pre the Enlightenment. We talk about the climate scientists as the authority. Mm. When the mainstream media are confronted with two different versions of what might be going on in the climate, they go, well, how do we find out? Well, we call the highest authority, that'd be this person over here, they're government climate scientists, and they call them up and ask for their opinion, and they find out the government climate scientist's point of view. Mm. But there's a problem with that. For 3 decades now, the CO2 theory has reigned in government climate science. Mm-hmm. The government is the only people who employ climate scientists. And to voice any opposition within climate science circles, remember I used to work for the Department of Climate Change, is a career wrecker. That's been going on for 3 decades. So they only hire people who believe in the CO2 theory, and your career only thrives if you believe in the CO2 theory. So it's sort of normal that after 3 decades, most of the world's climate scientists would agree with the CO2 theory. Mm. But it doesn't mean they're right. Now, in this day of the internet, anyone can download the data. Mm. And as lots of technically adept non-climate scientists, such as myself, can attest, you download the data, you look at it, and you rapidly come to an opinion that's quite different from the climate scientists. It's not very difficult.
So why then? I mean, these are scientists. They're interested in the truth. We do live in a post-Enlightenment world. Most people are taught in high school, at the very least, the value of going back to the data, testing your theories and so forth against empirical, a theory has to be falsifiable. Yes. The various principles that apply to the scientific theory. You are essentially saying that there are a huge number of scientists who are not in any way being true to the scientific method.
Sadly, yes. Now, there is a certain amount of ambiguity about this, and the data accretes slowly over time. So what once looked like a safe position in favour of the CO2 theory has gradually turned around. Mm. But scientists are people too. We have mortgages, kids. We don't want to lose our job. If you're a climate scientist and you're a 40 or 50-year-old climate scientist and you lose your job or you're thrown out of favour because you voice opposition to the CO2 theory, where are you going to go? Mm. So it's easy just to go along to a certain extent. Some people do, some people don't.
Now I'm noticing just a thing that's come up a couple of times. When you first spoke about your conversion, as it were, you spoke about the accruing of data as it came in, changing your mind. You spoke then again about the accruing of data and that things have changed. Do you feel that it was once scientifically valid, or it was a valid scientific position based on the available data in, say, 1999 or whenever it may have been?
1980. 1980 was the time, around the time that the theory was proposed, and at that stage, it looked like a viable theory. Mm. It was based on a number of very large assumptions about how water vapour in the atmosphere works, for instance, but it looked like it was a possibility and therefore ought to be pursued. Mm. If it turns out we were going to overheat the world dangerously through release of CO2, we needed to know about it. Mm-hmm. So it was quite proper that a lot of the world focused on it. We had the IPCC set up and so on. Mm. But by the time we got to the mid-90s, the rate of warming had started slowing down rather. Sorry, it had started slowing down warming because, even though CO2 was still going ahead, being emitted at record rates. Mm-hmm. And some of the other information about water vapour in the atmosphere was starting to come in, and it did not agree with the theory. Mm. Right, this is where theory and data are at odds, particularly with that water vapour. That started coming in the mid to late 90s. Mm. And at that point, people should have had a look at the theory and said, no, I don't think this is right. That amplification, that's an intrinsic part of the theory that provides 2/3 of the warming in the climate models, isn't occurring. Mm. And at that point, we should have started backing off. But during the 2000s, it gets even worse. The data keeps accreting. It keeps not warming, even though we're emitting more than carbon dioxide than we ever have. A quarter of the humans' carbon dioxide emissions in the whole of history have occurred since 1998. yet the temperature hasn't gone up.
Yeah.
Something's wrong. So the data keeps accreting. Now, what happens, Topher? What happens if over, say, the next 4 years, the temperature drops by half a degree? It's only gone up half a degree since 1950, right? So if we reverse that warming, at some point, everyone has to back off and say, no, the theory is wrong. Look, it's really, the temperatures really aren't doing what we expected them to do. Okay, and for each individual, the point at which you say, nah, look, the data's not really matching the theory might be a little different. So we can allow a certain amount of tolerance. But at this stage, I think you have to say that the data is pretty overwhelmingly not agreeing with the theory.
Right.
And we're seeing that in the climate science world. The climate scientists are starting to look around widely for additions to the models, excuses about why things are not working to do with aerosols. They're starting to change their models. They're starting to look around for different ideas. Okay, the stress of it is starting to get through to them. These are scientists, and you can't be written off. You know, they should be doing their job, and they're noticing that things are not working the way they expected to.
Now, you made a submission to the inquiry into carbon tax pricing mechanisms here in Australia, in which you started by declaring that global warming has become a scam. Now, I talked before about your own personal progression and how it seems that things had continued for you from being a believer in the early 2000s to the point where you're here now. But calling it a scam is very, very strong language, particularly when you're talking about fellow scientists, people in the scientific community, and it's got to be one of the strongest possible statements against the IPCC and various other climatological and scientific bodies who support the theory. Now, you listed in that submission 4 pieces of evidence that show, in your view, that the current state of climate science is fundamentally flawed. You listed exaggerated temperatures, you listed a lack of ocean warming, which we have discussed, a lack of tropical hotspot.
Yep, that's the amplification.
Yep, and the outgoing radiation as measured by satellites. I'd like to revisit, in particular, the ones that we haven't really talked about yet. What do you mean by exaggerated temperatures?
Well, the only record we have of temperature changes, say from about 1850 or 1880 through to the satellite era, which began in 1978, was land-based thermometers. And the world was increasingly putting a number of land-based thermometers through the 1800s and 1900s. So there are records on lots of land-based thermometers. The problem is how the people in the climate science community have adjusted that data and interpreted that data to create a global a global temperature record. Now that global temperature record assumes all sorts of adjustments to the data. Well, I won't go into all the technical reasons for it, but on the face of it, it looks very odd. For instance, the raw data, the unadjusted data, shows that the United States was warmer in the 1930s than it has been in the last 2 decades.
That's if you simply take the measurements as they came out of the measuring instrument, no adjustments whatsoever.
That's right. Whereas if you go to the global warming record, and just for the United States part of it, they show half a degree warming or so. That's very significant because the United States is the best measured ground in the world, has the best thermometer network. There are issues with the siting of thermometers. Thermometers start off in a good site, but the city, on the outskirts of a city, but a city will expand and soon there's asphalt and cars and so on all around it, which has an urban heat effect, which can raise the temperature around that thermometer easily, half a degree, 2 degrees.
It's interesting you mentioned that because I actually walk past one such station in the northern suburbs of Melbourne on a regular basis, and I've often looked at the little, the wind vanes spinning and so forth, and wondered at the fact that you've got a 5-lane major road on one side and another major arterial road on the other side, and cement pretty much everywhere you look, and yet that's still being used.
Yeah, it's a problem there is that thermometer is probably measuring the heat from that asphalt and from those cars. It's measuring the growth of the city. It's measuring the growth of traffic.
Well, the urban heat island effect is well established and very well understood. So, but surely they would have to then make adjustments to the data in order to account for those effects. Surely they would be aware of those effects.
They are aware of those effects, but the adjustments often go in the other direction, always in the warming direction.
Right.
We don't think they have been adjusting those correctly, and we're very suspicious of the use of badly sited thermometers and the use of adjustments that always push the temperature trend upwards.
Which is how you believe the US temperature record has gone from
That's right.
its native, its unadjusted figures to the adjusted figures. I would like to dive a little bit deeper.
If you've got urban heat adjustment, you would adjust your temperatures downwards. But if the raw temperatures were higher in 1930 than they are now, surely the actual temperature will be lower.
Would be even lower again. So what are some of the reasons that they give? I mean, again, we're talking about human beings here. I don't believe for a moment that they're sitting there rubbing their hands together as some evil mastermind with some plot at stake. They must believe that they have legitimate reasons for making the adjustments that they do.
Well, they're convinced that the CO2 theory is correct, and they're rewarded for data that shows that the CO2 theory might be correct and looking better. And it's a subtle thing, but data that doesn't agree with the theory is kind of neglected, and the people who produce it are kind of neglected too.
The headlines go to the people who
Very
provide.
much so.
Yeah. Now, one such example might be considered to be Michael Mann's hockey stick. I don't know if you want to go into that at all specifically yourself. I don't know if that's an area. Yeah. Well, I'd be interested to hear your thoughts on that, because that was one that did do the rounds. It's one that a lot of people have heard of, certainly the hockey stick itself, and then quite a high percentage of people are also aware of the fact that there was something not quite kosher about that. So
there's a lot not quite kosher. The work itself is kosher enough. It's the representation of his work that is very wrong.
Okay.
He represented it as a multi-proxy series that covered the globe, or the Northern Hemisphere rather, and gave you a representation of the temperatures over the last 1,000 years.
Right.
It's nothing of the kind. He set it up so that really only one proxy mattered. A proxy is a way of measuring temperatures before we had thermometers. It might be something like tree rings or stalagmites or sea creatures. There's lots of indirect ways of estimating temperatures. But it turns out that his hockey stick, due to the procedures he used, basically looked for what are called hockey stick shapes, where the temperature is flat for a long time, then suddenly perks up starting in 1910. And lo and behold, there was one proxy amongst the many he looked at that had that shape. It was due to something called the bristlecone pine. It is a very special species of tree that grows near the snow line, particularly in North America.
Right.
Now, this particular species of tree is not temperature or water, is temperature and water, particularly water constricted, and in effect, the main limitation on the growth of this tree is the level of CO2 in the atmosphere. So when the level of CO2 in the atmosphere perked up, starting with industrialization, particularly after World War II, so did the growth of this tree. Now, in his construction of the hockey stick, Mann included other proxies, but they were given ridiculously low weights so that they didn't affect the result. And effectively, his hockey stick just shows the growth of bristlecone pines.
Which is essentially a proxy for atmospheric CO2, which we know has been rising.
And that's why his representation and the use of the IPCC, Mann's graph, is essentially a fraud. Now, the IPCC have implicitly recognised this. In the third assessment report in 2001, Michael Mann's graph was shown in 6 places in glorious colour and given lots of publicity. The IPCC even changed its logo to show a hockey stick. By the 4th assessment report in 2007, all references and all pictures of Michael Mann's hockey stick had been deleted, and the logo changed.
Right. Well, I think that pretty much tells us everything we need to know about that one. So, exaggerated temperatures, the lack of a tropical hotspot. What's a tropical hotspot? What's the significance of that?
Tropical hotspot is the action of water vapour. Now, you see, in the climate models, when they look at the past and they try to fit up how well the climate models have predicted past temperatures and how they're going to predict future temperatures, 2/3 of the warming comes from water vapour action. Only 1/3 comes directly from the carbon dioxide. Yes, carbon dioxide is a greenhouse gas, and when we put more in the atmosphere, it will warm the planet. But the question is how much?
Right.
And the how much is answered by climate models.
Right.
It's a question of modelling and estimation, and calculation. It's not measured. Right?
So this water vapour is supposed to increase as a consequence of CO2.
Yes.
So it's a feedback loop.
That's right. It's a positive feedback. The way it works, if you put more CO2 in the atmosphere, you'll get more warming around the surface. Most of the surface of the Earth is ocean, about 70% of it. So that means you get more evaporation, right?
Yep.
And evaporation means there's more water vapour in the atmosphere. Now, water vapour is in fact the most important greenhouse gas. CO2 is only the second most.
Okay.
Water vapour is up there, but it's a greenhouse gas, so it's going to warm things even further, right? Which is going to cause even more evaporation, and so on. So it has an amplifying effect.
Okay, and so
that was the assumption made in 1980. If it was true, the world could be in a fair bit of trouble.
Right.
We could be heating the world.
And that's what the models have been telling us, that we are going to be in a lot of trouble.
And the models are based on the idea that nearly all the past warming and all the future warming is due to CO2 and this water vapour amplification. Right. And the ratio roughly 1/3 to 2/3.
Right, okay.
But then we look for the evidence that this water vapour amplification is actually occurring in the atmosphere. The evidence for it would be a tropical hotspot, particularly over the tropics where most of the warming occurs.
Right.
There would be more water vapour, therefore pushing up to higher levels of water vapour. So what was previously cold, dry air would be replaced by warmer, moist air. So that area would show up as a bit large increase of heat, which would be a water vapour, a hotspot. Also, there'd be latent heat. The water vapour carries up latent heat, and when it condenses in the atmosphere, it would release a lot of heat, that so-called it's converting from latent heat to sensible heat. And so that would produce a hotspot as well. So you should get a hotspot over the tropics, about 10 kilometres up, a large warming occurring during the periods of global warming.
And who predicted this hotspot?
Everyone. All the climate
So the
models
IPCC?
Oh, completely.
So this isn't something that you've come up with?
Look at any atmospheric warming diagram
right.
that has been published from any warming climate model in the last 30 years. They've all got a hotspot.
Okay.
But here's the thing. We've been measuring the atmosphere since the late 60s using weather balloons.
Yeah.
These weather balloons ascend through the atmosphere. They've got a temperature, a thermometer and a radio. They send back the temperatures. And we've been doing it from 900 locations twice a day. Millions of these things have gone up. It's not a casually measured thing. We've been measuring what's going on in the atmosphere. They show no atmospheric hotspot at all, not even a small one. It isn't occurring at all. So that's a pretty solid clue that the amplification that's providing 2/3 of the warming is simply not occurring, which is a pretty big clue that the CO2 theory is much exaggerated.
Well, if all of the models are factoring that in and we're simply not finding it, well, you would think on the face of it, be a pretty good reason to reassess the models.
It's a major scam, and the other side have been hiding it. For instance, at one stage they came out and said, "Oh, we did find it," and they produced a graph with a large hotspot, but it turns out that the colour red where they'd made the hotspot was for zero change on the scale. So they trumpeted that for about a year until people pointed out it was an obvious fraud, and then they dropped it again.
Yeah.
It's got to that stage. People on the other side will openly dissemble about it and exaggerate and make stuff up to sort of give the impression that they did find a hotspot, but it is a major scandal in climate science that they haven't found it. And it's a major scandal in the media that they haven't pressed hard enough on this issue to uncover it. It's not exactly difficult to understand. I mean, we understand the concept that CO2 is a greenhouse gas and traps heat like a blanket. Well, it's not very hard to understand that water vapour is also like
the same thing.
It's amplified, and so we should see this hotspot, but the hotspot's not there. So what gives? The answer is that it's not CO2 that's causing most of the warming we've seen in the last century or so. It must be something else.
Something else is driving it. Let me move on to the fourth thing that you pointed out in your submission to the inquiry into carbon tax pricing mechanisms, and that was the outgoing radiation as measured by satellites. Now, this has actually been a point of particular interest of mine in the last year or so as I've become more interested in this subject and begun to research it for my own purposes. This is again an essential part of the climate models, is this belief that the Earth was not going to emit more heat as it warmed or something. You can probably explain it a lot better than I can.
Yes, the idea is that on a scale of weeks and months, if it gets a bit warmer, there's a lot more evaporation. So we see that amplification mechanism, the blanket of water vapour keeping the heat in will get thicker. And so the idea is that in those weeks and months, even though the Earth is hotter, it would in fact be emitting less radiation to space.
So it's another positive feedback loop.
It's again evidence of that strong positive feedback that the whole theory relies on. Well, as it turns out, we've been measuring outgoing radiation since the mid-80s with the Irby satellites.
Right.
And they show that in event after event, there's about 13 of these events that have been studied, where there's been an increase in the terrestrial temperature on the ground. We look at the outgoing radiation. Does it fall or does it rise afterwards? It increases, it rises. The climate
so it's not being trapped.
Climate models say that outgoing radiation should fall, but in fact it rises.
Yeah.
Again, corroborating the evidence from the lack of hotspot, the amplification isn't there.
Yeah. So when the temperature is increasing, the evidence is that it is simply escaping more quickly than it was before.
That's right,
As
you would expect.
Yeah, it's not being
Who would
trapped.
have believed that? It gets warmer, more heat gives off.
All right, so you said in Climate Coup in 2012, so this is where we're now getting much closer to your current work and your current position on the subject, that you've checked the main predictions of climate scientists and found they got them all wrong.
Yes.
Now that's, again, big statement. I mean, we've been progressing through some...
Well, the data is accreting. We've now got more data than we had, say, in 2008.
Right, okay. So, excuse me, whose predictions were you using? Whose predictions were you checking? How did you check them? You would want some pretty solid evidence to be able to come out and say that.
Exactly. I look at the data. Let's start with air temperatures. The best prediction they made of air temperatures, the earliest one that they definitely can't wiggle out of, was in 1990 in the first assessment report of the IPCC. Prior to that, they had models and stuff, but maybe they didn't have sufficient authority. 1990, they said in the summary for policymakers, they said, we think the temperature will go up at 0.3 degrees per decade. Maybe as much as 0.5 degrees per decade, but at least 0.2 degrees per decade.
Right.
Now we go to the internet and we can look at the 5 major temperature sources as measured by humans now. It's the RSS, the UAH for the satellites, NCDC, GISTEMP and HADCRUT for the land thermometers. All 5 of those data sets show less than 0.2. They show between 0.12 and 0.17 degrees per decade from 1990 through 2012.
Remind me again, what were the predictions?
Predictions in 1990 were for 0.3 degrees per decade.
Right, okay, so
Minimum of
approaching
0.2.
double. Yeah, okay.
And in fact, all of them have fallen below that. The highest one in reality is 0.17,
Yeah.
and the lowest is 0.12. So it's a definite miss. It's not a huge miss, but it's a miss.
Why are there variations between these 5 measurement sets?
There are lots of reasons. A lot of them are just measurement uncertainty. They're not particularly important. They all basically agree with one another.
Okay.
Let's look at some of the other data sets. The ocean temperatures is a much bigger miss.
Right.
Ocean temperatures have only been measured properly since 2003 by the Argo program, and they show essentially no warming since the measurement started in 2003.
Right.
Well, the climate models say it'd be going up at a fairly brisk clip. It's not. So that's a second failure. That's a huge one. So the air and the ocean aren't warming.
Right.
Then we get to their predictions about the amplification. They say there should be a tropical hotspot. There isn't one. And they say that when the Earth heats up, you should give off less radiation because of the trapping effect. But no, more radiation is giving off. So they get that backwards as well.
Yep.
So their amplification is wrong or backwards, and the temperatures aren't going up the way they say they are.
So they're none
It's a
from
pretty
4 at the
damning
moment.
ensemble of data versus the theory. This is post-Enlightenment. We put data versus theory.
Yep.
Which one are we going to throw out? Post the Enlightenment, you should throw out the theory, all right? But that's not what's happening in climate science. In climate science, they're saying, oh, we don't like the data, the theory's definitely right, so we don't like the data, let's just hang in there and see what happens.
See what we can do. Now, Dr. Evans, you've had a look at essentially the mathematics that underpins the 50 to 1 project. It's that arrives at the conclusion essentially that it's 50 times more expensive to try and stop climate change than it is to adapt to climate change as and if it happens. And that is if we assume from the beginning that the IPCC is correct. What are your thoughts on that? What are the implications, given that Australia has an a carbon emissions reduction scheme? The European Union have their own trading scheme. There are various schemes operating in various parts of the world. How should we be dealing with climate change as an issue? And what do we need to do in terms of a legislative response, given the situation that we're in Australia now?
I think what we need to do is look at the money. This is all about money. The ETS, the carbon tax, the renewables effort, all have winners and losers. They take money from some people and give it to other people. This is on the basis of a theory that is not supported by data anymore. Well, it never was, but it's now definitely contradicted by data. So you just have to ask yourself, who's doing it and why? And as any good journalist should do, you should follow the money. So who are the people receiving this money? And where's it coming from?
When you say this money, what are you referring to there?
Well, since 1990, $100 billion has been spent on climate research and trying to prove the CO2 theory. That's a fair bit of money. There's a similar amount of money going into renewables research, and there's a lot of money going in worldwide into deployment of renewables. Australia spends, I think, a couple of $1 billion every year on renewables. That sounds warm and cuddly and fine, but it might be completely unnecessary. And wouldn't $2 billion be better off spent on, say, medical research? This country spends about $800 million a year on medical research. Would you rather have a cure for cancer or a few windmills built by carpetbaggers for a non-existent theory?
One of the objections that I hear to the idea that we're spending too much on renewables and green efforts is this idea that, hey, what if we are wrong, and what if CO2 isn't a problem? Well, then all we've done is created a cleaner environment and made for a better world because of all the efforts that we put in trying to deal with the problem, even if it turns out to not be a problem. But you're saying essentially the opportunity cost or the other things we could have done with the money?
Of course, we'll have wasted a massive amount of time and effort and resources on something that simply didn't matter. And that's never a good idea. We could have improved our lives. We could have improved the lives of others in countless ways with that same money and effort. And here we are wasting it on the basis of a theory that has now been disproved. Anyone can look at that data and see that the theory is not right. So why are we continuing to waste money on it? Do those people we're wasting money on it, do they have an undue influence on policy perhaps?
Well, it's interesting because the carbon tax was only introduced very recently. Here in Australia, it was introduced, many people would argue, and I would be one of them, for fairly cynical political reasons. Julia Gillard's desire to achieve the status of Prime Minister after a very, very close election, needing the support of the Greens and therefore introducing the carbon tax for that reason. From what you're saying though, and the timeline that you're giving, This was already after the point where a lot of the evidence that convinced you, and in your opinion, you seem to believe should have convinced a lot of other people to really question the theory, had already come to the fore. A lot of the evidence that contradicts anthropogenic global warming as a theory was already well known by the time we hit 2011 thereabouts.
The theory should have been abandoned in the late 90s when the amplification was definitely missing. But this area is full of fraud. Let me give you another example. Al Gore's movie, An Inconvenient Truth, only presented one bit of evidence that CO2 was causing a problem. He showed us the ice core records. Remember, he stood on the elevator and did the ice cores and said, look, temperature and CO2, they're moving in lockstep. Well, that's true of the ice cores that were done from about 1985 through to about the late 90s. And in those ice cores, the time resolution was really poor. The time points are a couple of thousand years apart. Okay? But starting in the late 90s, we had better ice cores. And then we could see data points that are only tens or hundreds of years apart. And what we discovered, to everyone's satisfaction, and it is now not controversial, by 2003, everyone knew that in fact the temperature went up 800 years before the CO2 on average. So it was the temperature rise causing the CO2 rise, not the other way around. Now here comes the fraud. Al Gore made his movie in 2005. Al Gore knew perfectly well, and his advisors would have known perfectly well, that what he was suggesting was wrong. And in fact, if you go back and look at An Inconvenient Truth, he put some lawyer-like weasel words in front of that section to try to not suggest exactly what he was suggesting.
Right. So he leaves you with one impression, but has a fallback.
Exactly. Now, the politics of this stinks, because over and over again we see a political system that's pushing this idea and pushing the consequences. They want regulation, they want this green stuff, they want money to go to certain parties, and always the data they quote is wrong.
Now, what I find interesting, though, with the ice core issue specifically, you're saying that CO2 lags behind temperature.
Yes.
So there is a relationship.
Of course.
Is it a causal relationship?
Yes.
And we're seeing what temperatures are in?
Yes.
What's the
mechanism? A Year 12 chemistry
for that?
student would be able to tell you, Topher.
Right. What's the mechanism?
Well,
can we explain that?
The carbon dioxide is a gas. It exists in the atmosphere, but also exists dissolved in the water below, in the oceans.
Okay.
And any dissolved liquid will tend to come out of the liquid as you heat the liquid. Okay. There's 50 times as much carbon dioxide dissolved in the oceans as there is in the atmosphere. You just warm up the oceans a tiny bit, and some of that water, CO2 from the oceans moves to the air.
Right.
And in the past, in those at the end of glaciation periods, when the world warmed up for a warm interglacial period, the oceans warmed up a bit, released some of their CO2, and so the CO2 rose 800 years after the temperature. So yes, there's a causal relationship, but not as Al Gore and the current CO2 theory is suggesting, that the CO2 rises cause the temperature to go up.
It's like saying that the grass being wet causes rain.
Yes.
It's the wrong way around, yeah.
So there's about 800 gigatons of carbon dioxide in the atmosphere, and there's about 40,000 gigatons, 50 times as much, in the water itself, in the oceans. And so every time you change the temperature of the oceans, if you warm the temperature of the ocean, increase the temperature of the oceans, a little bit of that carbon dioxide goes into the atmosphere and causes warming. Now, carbon accounting is a tricky thing. It's not clear that our carbon emissions are really raising the atmospheric level of carbon dioxide very much. Again, it's a quantitative argument. Let me explain. We know from the atmospheric bomb tests, nuclear bomb tests that were done from 1945 through 1963 when atmospheric testing was banned, that a particular isotope of carbon called carbon-14, which is rather peculiar to the bomb tests, like any other form of carbon dioxide, has a half-life in the atmosphere of about 5 years, which is to say the amount of it goes down exponentially with about a 5-year half-life. And so any carbon dioxide we put up in the atmosphere has a half-life of about 5 years in the atmosphere. That's interesting. Another factoid is that we only emit about 4% of the carbon dioxide that's going into the atmosphere. The other 96% comes from natural sources, predominantly the ocean, but also vegetation, release of carbon dioxide from vegetation. Now the ocean and the vegetation suck it all up again the next year, but we're only releasing 4% of the carbon dioxide that's going up there. How can our measly 4% be affecting that so drastically? Now here's the thing. The amount of carbon dioxide in the atmosphere, the rate it's going up, is only consistent with a half-life of 35 years, at the very minimum. That is to say, the amount of carbon dioxide in the atmosphere over the last few decades has been going up at a rate consistent with our emissions having a half-life of 35 years. But we know they don't. They only have a half-life of 5 years. The accounting of carbon in the atmosphere simply doesn't add up. Something's very wrong there.
So what you're saying is there's got to be carbon coming from somewhere else. If I understand correctly, the human increases don't account for the increases that we're observing.
Yes.
Therefore, we have to assume that carbon is also coming from somewhere else.
Yes, or something else is happening along those lines. Yes.
Right, okay. Now, that would be consistent with the ice cores that we were talking about a moment ago, where we have seen very significant natural variations in atmospheric carbon dioxide throughout history.
But we know the oceans aren't warming.
Right.
So it's not that. Exactly, we don't know. There's something else going on.
Okay. Now, on that issue, we know the oceans aren't warming. We know the atmosphere is not warming.
For the last 15 years or so.
Excuse me, yes. We know that there was a warming, at least in the atmosphere. As you've pointed out, we didn't have reliable measurements for the ocean up until very recently, but we know that there has been warming in relatively recent past, in particular, I believe, 1940 to 1970.
Even more relevant, can I just cut in a little bit?
Yeah.
We've been warming since 1680, the depths of the Little Ice Age. The temperature's been going up about 0.5 degree per decade on average, with some fluctuation.
Per decade?
Sorry, per century.
I was going to say, that's surprising, yeah.
0.5 degree per century, right, give or take, since 1680, which is the depth of the so-called Little Ice Age.
Right.
So that's over 3 centuries.
Right.
Whereas human emissions of CO2, 90% of them have occurred, all emissions in human history have occurred since 1945.
Phew.
Napoleon did not go to Moscow in SUVs. There's very little carbon dioxide emitted by humans before about 1910, and even the stuff before 1945 is pretty insignificant.
Yeah.
So what caused the warming between 1680 and 1945? If it wasn't human CO2, it must have been something else. And is that something else still operating? Is that the cause for the warming we've seen from 1975 through 2000? Okay, the world kind of cooled between about 1945 and 1975, just cooled, stayed about the same.
Yeah.
And then there was a big spike up, a big increase in the order of 0.5 degree or so from about 1975 through to about 2000. But we don't really know what caused that. We know the CO2 theory is a bust because the amplification didn't occur. And we also know that the world has been warming for the last 3 centuries due to something that can't have been our carbon dioxide.
And that we're not accounting for in our models.
No, we don't. Now, they'll say they account for it because they pay lip service to it and they put a little line in there that does something about it. In any meaningful way, no, they don't account for it in the models.
Now, something that's been a point of controversy that I've noticed in my research, the medieval warming period.
Yes.
There's some controversy, there have been attempts to say that it never happened, that it was localized. Yes. There have been other people saying that it was global, that it was significant, that it essentially disproves anthropogenic global warming as a theory because we were warmer back then. Fill me in on the medieval warming period. What's the deal with that?
I think George Orwell had the right take. He who controls the past controls the future.
Okay.
If you can have the idea that there was a medieval warm period and it was about as warm as it is today, then you say, well, what's so special about today's warming? How do we know it's due to our CO2?
Well, what evidence do we have that there was one? That we were once as warm as we are today?
Oh, well, proxy studies around the world. Hundreds of them, done by hundreds of researchers. I think the latest statistics I saw was about 800 peer-reviewed papers show that there were 90% of, on the medieval warm period, 90% of them say there was a medieval warm period, slightly warmer than today, and a few say it was a little bit cooler.
Okay.
These are over, I think, something like 200 or 300 different research institutes.
Different authors and so forth.
All from all over the world, except, by the way, Australia. As it happens, there's very little proxies on this continent that we can rely on. But basically, worldwide, there was a medieval warm period. We're not exactly sure of the magnitude, but it was roughly similar to today's temperatures.
So what would that say? Why have there been attempts to dismiss it or attempts to localise it?
Because the warmists would prefer the Michael Mann hockey stick view of the world, which was the world was exactly the same temperature for many, many eons, and suddenly humans came along and introduced carbon dioxide, so the temperature started going up. Which is obviously wrong, as soon as any look at the historical record is entertained.
It's interesting, the equilibrium theory. That's something that I encountered in the very early days in my schooling, when there was a great deal of concern about the hole in the ozone layer. And that was when I was first introduced to this idea that Earth had been continuously unchanged for a great deal of time, and that any variations that we see must be indicative of a change that's being forced onto the planet. And I think we're seeing the same thing with CO2 and with global warming theory. So where are we headed into the future? And if we don't even know what's driven these changes in the past, we can't account for the increase, for example, or the magnitude, of the increase in atmospheric carbon dioxide. What does that say about our ability to predict what's actually going to happen?
Well, one effect of the CO2 debate and the debate over global warming is it's directed a lot of scientific attention on these issues. I think you'll find within the next year both of those problems are solved. We'll know what did drive the temperatures for the last few millennia, and we'll know something about where the CO2 is coming from. I think just sit back, science will solve it eventually. Now, official science is getting in the way.
Okay.
Official science is not funding these problems very well. It prefers its CO2 theory, and the people working on the CO2 theory and the political people behind the CO2 theory tend to try to knock down other theories.
Right.
For instance, if you say anything like I have, pointing out there's no evidence for the CO2 theory because the amplification is missing, or the temperatures aren't going up, you get called all sorts of names in the media. It's rather discouraging. It discourages people from saying anything about it. And you can suppress that for a while, but you won't be able to suppress it forever, Topher.
Yeah.
And these are scientific truths. They're not politically malleable truths. The political crew have got into this and tried to make it malleable and tried to create the true perception in this sort of postmodern world, but it's not really working out for them because what's underlying it is hard science and reality as measured by instruments. And ultimately, the instruments and reality will win through. And I'm saying it'll probably take another year or two.
Well, that's an extremely short timeline, in my opinion. I mean, we've been dealing with anthropogenic global warming as a hypothesis since 1980 in a big way. It's certainly dominated politics for most of my adult life. The science may change radically in the next year or so. I'm certainly not going to try and argue with you on that point. You know a lot more about that than I do. Can the politics of it change that quickly, though?
That'll be a very interesting question. We've got the internet now to bypass the mainstream media. So when people like Murray Salby and others come out and show that the CO2 is not quite the way they thought it was, and maybe the sun is driving or something else is driving the temperatures, it has done for the last few centuries, how are they going to suppress that news indefinitely? I think, particularly with the temperature pause, and if there was, God forbid, if the temperature, say, dropped half a degree over the next 4 or 5 years, I think the public would be ready for another explanation.
Now, you've dropped that example on me twice so far this interview, dropping half a degree in a relatively short period of time. Is there a reason for that, or is that just something that is there something we need to know about?
The temperatures hasn't gone up for now for 15 years or thereabouts, whatever.
Yeah.
What does it take for people to go, no, I think this theory is wrong? Maybe the answer is something just utterly definitive, like a sizable drop in a relatively short period of time. They're expecting warming to resume with a vengeance very soon. In fact, it should have resumed, several years ago, but they're expecting it to resume with a vengeance very soon. Well, if that continues to not happen, or even, God forbid, go the other way, surely people will walk away from this theory.
Well, I remember when the pause in warming had reached around about the 10-year mark, a lot of people were saying a similar thing, though. And here we are 5 years later, the theory kicks on, the theory lives on.
Politics versus science.
Yeah.
Post-Enlightenment versus pre-Enlightenment. Postmodernism versus science. Gotta love it.
Yes, indeed. Well, Dr. Evans, thank you very much. And is there anything you just want that we haven't covered that you'd like to bring up, something that I didn't discover in my research that
They're the main points.
Yeah,
that'll do.
We've done the main stuff. Well, thank you very much. It's been a pleasure.
Thank you.